Okay, today we're going to be talking about hyperbolas, and let's just review here. If we have just this basic shape right here, then that is just a parabola. But if we have two parabolas that are connected to each other, then that is going to end up forming an ellipse. So let's say we have a parabola here and a parabola there. That's going to be an ellipse. Now today what we want to look at is what's called hyperbolas, and hyperbolas are similar to ellipses, except the parabolas are going to be going in opposite directions of each other. So that's what we want to focus on today. Alright, so let's just make sure that we have some of the vocabulary down. Let's say we have, this is our x and y axis, and let's say the hyperbolas are going right and left. So we'll make one go this way, and we'll make another one go that way. So we have the center right here, and the distance from the center to the vertex is A, and the distance from the center to the focus is going to be C, all right? And the distance from the center to actually what's called the end of the conjugate axis is B. So maybe we'll put that in dark blue, or actually in red. So this will be B right there. Now the thing to remember with hyperbolas is that, and this is important, the letter that comes first determines which way it opens. So if x is first, if x squared is the first variable, then it's going to open right and left. All right. If y squared is first, then it's going to open up and down. So the transverse axis is not the longer axis, it is the axis in which the parabolas open up. So the transverse axis is going to have on it the following things. So let's just write that down. Transverse axis. On it will be, of course, the center, the vertices, and the foci. All of those will be located on the transverse axis. And we're going to see how all of this works out. Now, we also have something called asymptotes, and I'll show you those in the problems to follow. Notice that the Pythagorean relation is a little bit different here. It's c squared is equal to a squared plus b squared. In the other videos with ellipses, it was a squared is equal to b squared plus c squared. So we're going to talk about all that in the problems to follow. So in this first example, we have the hyperbola 4x squared minus 9y squared equals 36. And first thing that we know that we need to do is we need to divide everything by 36 so that we can get this equal to 1. So 4 over 36 reduces to x squared over 9, and then y squared over 4. And actually this needs to be minus. So actually let's just write this over again. So it's going to be x squared over 9 minus y squared over 4 equals 1. So we recognize that the x comes first. So let me circle that. The x squared comes first, so that is our clue that this is going to open right and left. So let's go ahead and see if we can sketch this. So our center is 0, 0. So let's just put that right there. And actually we will use a different color for the sketching. So we will put our center at 0, 0. And then we are going to go right 3 and left 3. And that's our A. We're going to go up 2 and down 2. Now, because x is first, that means right and left is where our vertices are going to be. So we will put a vertex at 3, 0 and a vertex at negative 3, 0. And now we're going to learn how to sketch hyperbolas. So what you want to do here is you want to make a little box. Actually, you know what? I'm going to do this in a different color so that you can really see it. I'm going to do it in green because I like green. So we're going to make a dotted line box. And you get this box by basically going up B, down B, right A, left A. And then you're going to draw what's called some asymptotes that are going to go through the corners of the box, through the center. And so let's go ahead and do it on this side. So you have some asymptotes coming through here. And now that's going to enable you to basically draw your hyperbolas. So that's going to look there like that, and then it's going to come that way, and then the other side's going to go there and there. So the dotted lines are there to guide your sketch. And let's see if we can answer all the questions that they're asking. Well, vertices, says here the vertices, and those are going to be 3, 0 and negative 3, 0. Our foci are always going to be located somewhere inside of the vertex and inside of the parabola. So therefore we need to find C. C is the distance from the center to the foci. So our equation is going to be C squared is equal to A squared, which is 9, plus B squared, which is 4. That's 13. So C is going to be root 13. So because this is on the x-axis, our foci are going to be root 13, 0 and negative root 13, 0. And so we have our foci, and even though this problem does not ask for it, we're going to find the equations of these asymptotes because you're going to need to do that later. So these asymptotes basically go through the origin. They have a slope of 2/3. You can see that because it's rise over run up 2 over 3. So these are simply going to have a slope of 2/3 with a y-intercept of 0, so you don't need to write that. And then the other line, which is coming down here with the negative slope, that's just going to be negative 2/3 x plus 0. And these are your asymptotes. So we've got our asymptotes, we've got our equation, we've got our center, we've got our vertices, we've drawn our box, we've got our foci, we've drawn our hyperbola. That's everything we need to do for this problem. Okay, example 2. Find an equation of the hyperbola with foci 0, negative 3, and 0, 3. So as always, first thing we want to do is we want to put our x-axis, our y-axis. So we're going to put those there. And then we are going to put our foci, so that's going to be 0, 3. It's going to be here. And 0, negative 3 will be there. And it tells us that, so remember, the foci are located on the transverse axis. So let's go ahead and put our center there. And so the conjugate axis has a length of 4. Now you got to be careful. That means it has a length of 4, so that means you have to go right 2 and left 2. All right, so now we may be tempted to draw our box, but we're not going to draw our box because remember, our box must go around the vertices, not the foci. So these points are foci. So we need to find our vertices. So we're going to do that because we know that C is 3. Our C is 3. Our B is 2. So we need to find A, which is the distance from the center to the vertex. So it's going to be 9 equals A squared plus 4. So A is radical 5. So I'm going to put in blue, radical 5 is about 2.2. So right about there and right about there are going to be our vertices. So now we can draw our box, which is going to go around our vertices. So basically it's going to go, that's going to be basically our transverse axis. This is our conjugate axis. And now we're going to draw some nice lines that go through the corners of the box, and we're going to go through the center. Alright, and now this time our parabolas are going to be going up and down, and that's because that's where our foci are located, that's where our vertices are located. So there is the first one, and then the next one is going to look like this. Now notice that because it's going up and down, we need in our equation for the y to be the first letter that we see. This is still centered at 0, 0, so it's going to be y squared over a squared. Remember, a is root 5, so this is going to be 5 minus, and then we have x squared over b squared, and b squared is just 4, equals 1. So don't forget, with hyperbolas it needs to be a minus. And then the last thing we need to find is are the asymptotes. That should be pretty simple. So y equals rise over run. Rise is root 5, run is 2. So root 5 rise 2 x. Once again, our y-intercept is 0. So that's our positive asymptote. And here's the one with the negative slope. So these are our asymptotes. Okay, in this third example, we are given the endpoints of the transverse axis. So that is another way of basically saying that they've given us the vertices. So because we know that the transverse axis, at the end of each transverse axis is located a vertex. So we're going to draw our x and y axis again, and now we are going to locate and put our points on there. So -2, -1 is here, and then 8, -1, 1, 2, 3, 4, 5, 6, 7, 8, -1 goes there. And so if we go from -2 on a number line to 8, that's a space of 10. So that means the center is right in the middle of that, so that's going to be 3, -1. So maybe we'll put that on our graph right there. And that's our center. So it also gives us, our vertex. It also gives us the length of the conjugate axis, which is 8, which once again means you're going up 4 and down 4. So up 1, 2, 3, 4, and then down 1, 2, 3, 4. So we can put a point there, although those are not any, they have no real significance. And so now we're going to draw our box. So we're going to draw our box. And our box, once again, goes around the transverse axis and the conjugate axis. So once again, we're going to draw our asymptotes through the corners and through the center. So this one needs to come from here, go through the center. All right. And so now we can draw our hyperbolas. So it's going to be coming from this vertex, and there it is. And there's another parabola coming from the vertex. So now we need to basically find the standard form of the equation, and we're also going to find the foci, and we're also going to find the asymptote, so that you are very comfortable with doing all of these things. So we are going to say x minus 3, because the center is 3, -1 squared, minus y plus 1 squared, divided by a squared. A is the distance from the center to the vertex. That's 5, as we said earlier. So that's going to be 25. And then the distance from the center to the other part of the box is 4. So that's going to be 16 when you square it, equals 1. So we've got our equation for standard form, but we're going to find the focus, and we're going to also find the equations of these asymptotes, because we are overachievers. So our focus is going to be located at a distance of c from the center. So c squared is equal to a squared, which is 25, plus b squared, which is 16. That's 41. So C is root 41. Now it means you have to go from the center a distance of root 41. So that means you're going to the right, which means you're adding root 41 to the x-coordinate of the center. So that's going to be 3, the x-coordinate of the center, plus root 41. Let me write that a little better. Root 41, comma, well, the y-coordinate of the focus is the same as the y-coordinate of the center, so that's just negative 1. Now this one is going to be 3 minus root 41, comma, negative 1. So there are our two focus points. And then now we have to get our asymptotes. And this is where we need to use this equation right here. And h and k is the center. So the slope is going to be rise over run. So up 4 over 5. So y equals 4/5. And then it's going to be x minus the center, 3. And then plus k. So it's going to be minus 1. All right. And that is the first asymptote. The second asymptote will be negative 4/5 x minus 3 minus 1. So those are the asymptotes. These are the foci. Here is the standard form of the equation of this hyperbola. And we've gotten everything that we need for this problem. Okay, here we have this last example here. So once again, we are going to draw our x and y axis. And there we go. And we have the equation given to us. We just need to find the center, the vertices, and the foci of the hyperbola. And of course, we are going to sketch it as well. So we're going to go, so our center, that should be pretty easy to find. Our center, let's just write it out here, is going to be negative 2, 5. So that's going to be left 2 and up 5. 1, 2, 3, 4, 5. There's our center. And the x is first. So that means that this is going to open right and left. So we are going to go right 3 and left 3. So right 3 is going to be here. And left 3 is going to be there. And let's get those coordinates. So if this is negative 2, 5, then you're going right 3, that's going to be 1, 5. That's our vertice. And then negative 5, 5. That's another vertex. And then we're going to go up and down 7. So 1, 2, 3, 4, 5, 6, 7 up there. And then we're going to go down 5 and then another 2. So there it is. So now we're going to draw our box. And our box once again is going to go through the transverse axis and the conjugate axis. And now we're going to draw our asymptotes. And so you can see that this is going to be a very wide hyperbola. So now we're going to sketch our hyperbola. So it's going to come this way and that way, and then it's going to go that way and that way. So very wide hyperbola. So we've got the center. Now we need to find the foci. And so we see that c squared is equal to a squared, which is 9, plus b squared, which is 49. So c is root 58, which means that from the center to the focus is a distance of root 58. So if our center is negative 2, 5, and we're going right, then that means we need to do negative 2 plus root 58, comma 5. That's our one focus. And then our other is going to be negative 2 minus root 58, comma 5. So those are two foci. Here's our center, our vertices we got, and if we wanted to get the asymptotes, we could do that as well. That would be y equals, we're going to go up 7 and over 3, so 7/3 x minus a minus 2, so that's plus 2, and then plus 5. And then the other one will be negative 7/3 x plus 2 plus 5. Okay, so up 7 over 3, rise over run to get the slopes of these lines. So we've got the center, we've got the vertices, we've got the foci, we've graphed it. That's all we need to do for these problems.